everyone, this is me again, Bianca Magdaong from IT2105. So for today's video, I'm going to tackle with you the summary of the chapter 4, which is entitled Network Access. So, whether connecting to a local printer in the home or a website in another country, before any network communications can occur, a physical connection to a local network must be established. So, a physical connections can be wired connecting using a cable or a wireless connections using a radio waves. Excuse me. So network interface cards, which what we call NICS, connect a device to the network. Ethernet and NICS are used for wired connections. An end user device may include one or both types of NICS. A network printer, for example, may only have an Ethernet NIC and therefore must connect to the network using an Internet cable. So other devices such as tablets and smartphones might only contain a WLAN NIC and must use a wireless connections. So to connecting to the wireless LAN with a range extender, all wireless devices must share access to the airwaves connecting to the wireless access point. This means slower network performance may occur as more wireless devices access the network simultaneously. So a wired devices does not need to share its access to the network with other device. Each wired device has a separate communication channels over its Ethernet cable. Then this is important when considering some applications such as online gaming, streaming, video and video conferencing, which require more dedicated bandwidth than other applications. So the process that data undergoes from a source node to a destination node is the user data is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the data link layer. Then also the physical layer encodes the frames and create the electrical, optical, or radio wave signals that represent the bits in each frame. These signals are then sent on the media at a time. So the process that data undergoes from a source node to a destination node is the user data is segmented by the transport layer, placed into packets by the network layer, and further encapsulated into frames by the data link layer. So the physical layer encodes the frames and creates the electrical, optical, and radio wave signals that represent the bits in each frame. Then these signals are sent on the media on one at a time. Then the destinations node physical layer retrieves these individual signals from media, restores them to their bit representations, and passes the bits up to the data link as a complete frame. So the three basic forms of network media, these are the physical layer produces the presentation and groupings of a bit for each type of media as copper cable, fiber optic cable, and wireless. So copper cable. So the signals are patterns of electrical pulses. Then fiber optic cable, the signals are patterns of light. Then wireless, the signals are patterns of microwave transmissions. So physical layer standards. So the protocols and operations of the upper OSI layers are performed in software engineers and computer scientists. So the service and protocols in the TCP or IP suite are defined by the Internet Engineering Task Force, or what we call IETF. So so the physical layer consists of circuitry, media, and connectors developed by engineers. So therefore, it is appropriate that the standards governing this hardware are defined by the relevant electrical and communications engineering organizations. Excuse me. So, encoding. So, encoding or line encoding is a method of converting stream of data bits into a predefined code. So, codes are groupings of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. So there are many ways to transmit signals. So a common method to assign data is using modulation techniques. Excuse me. Excuse me. So modulation is the process by which the characteristics of one wave or the signal modifies other wave or the carrier. So the nature of the actual signals representing the bits and the media will depend on the signaling method in use. So, bandwidth is the capacity of a medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. So, bandwidth is typically measured in kilobits per second or KB, or rather kilobits per second, megabits per second, or gigabits per second. So bandwidth is sometimes thought of the speed and bit travel. However, this is not accurate. For example, in both 10 megabits per second and 100 megabits per second. So Ethernet bits are sent at the speed of electricity. So the difference is the number of bits that are transmitted per second. So throughput is the measure of the transfer of bits across the media over a given period of time. So due to a number of factors, throughput usually does not match the specified bandwidth in physical layer implementations. So many factors influence throughput. So including the amount of traffic, the type of traffic, and the latency created by a number of network devices encountered between source and destinations. So latency refers to the amount of a time to include delays for data travel from one given point to another. So the physical layer produces the representations and groupings of bits as voltages, radio, frequencies, or light pulses. Various standards organizations have contributed to the definitions of the physical, electrical, and mechanical properties of the media available for different data communications. So these specifications guarantee that cables and connectors will function and anticipated with different data link layer implementations. So the timing and voltage values of the electrical pulses are also susceptible to the interference from the two sources. So the electromagnetic interference, or EMI, or radio frequency interference, RFI. So EMI and RFI signals can distort and corrupt the data signals being carried by copper media. Potential source of EMI and RFI include radio waves and electromagnetic devices such as fluorescent lights or electric motors. Then The crosstalk. So crosstalk is a disturbance caused by the electric or magnetic fields of a signal on one wire to the signal in an adjacent wire. In telephone circuits, crosstalk can result in hearing part of another voice conversion from a adjacent circuit. Especially when the electrical current flows through a wire, it creates a small circular magnetic field around the wire, which can be picked up by an adjacent wire rather. So so for further explanations of the summary of the chapter 4, so the TCP or IP network access layer is the equivalent of the OSI data link layer, which is layer 2, and the physical layer, which is the layer 1. So next, the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Then, the physical layer standards address three functional areas, which are the physical components, frame encoding technique, and the signaling method. So then, using the proper media is an important part of our network communications. Without the proper physical connections, either wired or wireless communications between any two devices will not occur. Then, wired communications consists of copper media and fiber cable. Then, there are three main types of copper media used in networking. These are the unshielded twisted pair, or what we call UTP, shielded twister pair, which we call STP, and the coaxial cable. So UTP cabling is the most common copper networking media. Optical fiber cable has become very popular for interconnecting structured network devices. It permits the transmissions of data over longer distances and higher bandwidths, or what we call data rates, than any other networking media. So next, wireless media carry electromagnetic signals that representing the binary digits of data communicating using radio or microwave frequencies. Then, the data link layer is responsible for the exchange of frames between nodes over a physical network media. It allows the upper layer to access the media and controls how data is placed and received on the media. Excuse me. Then next, among the different implementations of the data link layer protocols, there are different methods of controlling access to the media. These are media access control techniques define if and how the nodes share the media. Then, the actual media access method used depends on the topology and media sharing. So LAN and WAN topologies can be physical or logical. Then WANs are commonly interconnected using the point-to-point hub and spoke or mesh physical topologies. Then in shared media LANs, and devices can be interconnected using the star, bus, ring, or extended star, which what we call hybrid. So physical topologies. Then last, all data link protocols encapsulated the layer 3 PDU within the data field of the frame. However, the structure of the frame and the fields contained in the header and trailer vary according to the protocols. So guys, that's all for my today's video. Again, this is all about the summary of chapter 4, which is entitled Network Access. So guys, hope you like it. Thank you!